Okay, Algebra 2, we are up to 5-2. Title is Zero and Negative Exponents. So this is going to be a very short and sweet pre-lesson. I was thinking about skipping the pre-lesson, but I didn't see where I could put it on your actual hard copy. So we're just going to take a few minutes here and just talk about this. And this will explain it, I hope. So first of all, what's 3 cubed? Well, that's 3 times 3 times 3, which is 27. What's 3 squared? Well, it's 1 less 3. So I'm going to take this answer and I'm going to divide by 3. Now I'm doing it this way on purpose because my target is to help you understand zero exponent and negative exponent. So just stick with me even though I'm doing it the way you might not think of it. So what's 27 divided by 3? That's 9. All right, well, what's 3 to the first? Well, it's 1 less factor of 3, so I have to take my previous answer and divide by 3. And we know that 3 to the first is 3, but I want you to follow this pattern. Divide by 3, divide by 3. So look at this pattern, 3, 2, 1, 0. A lot of people, if I said, hey, let's do this really fast, what's 3 to the 0 power? You'd say 0. And that's mathematically inaccurate because look at it, follow the pattern. Divide by 3, 9. Divide 9 by 3, 3. Divide 3 by 3, what do I get? 1. There's rule number 1. Anything to the 0 power is 1. So what you're looking for are questions like this. X cubed y squared over z to the 4th, all to the 0 power. You want these, because what does this equal? Equals 1. How come? Because it's being raised to the 0 power. You gotta love that rule. Doesn't happen enough, but now you know those problems are the easy ones. But the real lesson is negative exponents, because this is going to happen a lot, okay? Not just in Algebra 2, but also trigonometry and calculus, and you need to know what to do with these negative exponents. Well, I've already established the pattern. So how do I get from here to here? Well, I divide by 3. Now watch what I'm going to do. I'm going to actually write this as 1 3 to the first. It's the same thing as 1/3, but I'm going to keep that little exponent there of a 1 because now I'm going to go from here to the next one. So I'm going to go 1 over 3 to the first. Watch this now, divided by 3, because that's what I'm doing every single time. So the pattern has to be take the previous answer and divide by 3. Well, this is the same thing as this. And remember, when you divide a fraction, or you divide by a fraction, the first stays the same. This turns into multiplication, and I'm going to tweak this a little bit. That's 1 over 3 to the first. Now remember, x squared times x cubed is x to the 5th. The bases stay the same, but then you add the exponents, and that's what we're doing here. So we get 1 over 3. See, the base didn't change? Add these exponents, squared. And I want you to notice something. There it is. So, you got to get used to Mr. Cleefish's language. My language is this negative, and it's true for this negative too, but I'm talking about this one. When you have a negative exponent, this is not a normal negative. It is a command. Here it comes. And the command is put me, I'm going to talk about what that is in a minute, where I ain't. Put me where I ain't. So, let's pause. If I asked you, if you're listening, if you take the trash out, let's say that's your weekly duty, and your mom or your dad comes to you and says, hey, Johnny, take the trash out, and you ignore it because you're playing games or doing the math, and you don't obey the command, I guarantee you that command is coming back. In other words, a command doesn't go away until you obey it. Think about that. And so what I'm saying is, put me, who's me? All of this, which is technically over 1. Put me, 3 squared, where I ain't. Well, where is it? It's in the numerator. Where does it go? Denominator. Where'd the negative go? Well, you obeyed the command. That's why it disappears. Now, I'm going to give you a real simple example just to get started. So, what does this mean? Well, it means put me, all that, down, and it says put me where it ain't, up. So this would be y cubed over x squared. Could you say flip it? Yeah, in that case you could. There's your warm-up, okay? Hopefully that'll help you understand when we get to these packet problems.